the absolute absurdity about this channel is that I'm, for some reason, doing this to myself. This is going to be just nasty and horrible and long to follow, but hey, it's all for those couple of views. So I'm going to find the convolution of this function here with itself given this function. So the convolution of two functions is defined by f little star gx, which equals the integral of minus infinity to infinity of fx minus y gy dy. So I'm going to call this 1 because we're going to refer back to this later. So we now need to find the Fourier transform convention, which is going to be, this is going to be my Fourier symbol. I mean, it kind of works, of fx k, which equals 1 over the root of 2 pi, and then let's do an integral from minus infinity to infinity of fx e to the minus I kx dx. We'll call this the equation 2. And then the inverse transform is going to be fx, which equals 1 over root 2 pi. And let's integrate minus infinity to infinity. That's my Fourier transform of the function f k e to the ix dx, and we're going to call this 3. So the Fourier transform of e to the minus x modulus, so let's do the Fourier of this, is going to be using fk. Man, I need to get better at doing, though that's a Fourier transform, yeah. So if I flick that out, that's the Fourier transform of e to the minus x k. We would then pull from this, so you're going to get f k equals 1 over root 2 pi minus infinity to infinity, and beyond. All right, I'll stop that. X e to the minus ix dx, which is going to be 2 over root 2 pi 0 to infinity e to the minus x cos kx dx. So let's get on to the next steps. So this cos kx, we know that cos kx is the real part of e to the ikx. So this is the exponential representation of the cosine. So now if we have the real part of infinity 0 to infinity of e to the minus x e I kx dx, we know that this would then go to, can I fit this in? Yeah, probably. The real of 0 to infinity e, we're going to now use the exponential rules of minus 1 minus I kx dx. We know that the integral of 0 to infinity is of e to the minus ax dx is going to be 1 over a. And we have a, which is this part here, a equals 1 minus I k. And since the real part of a is 1, which is greater than 0, the integral converges. So we can then look at this, and we now know that this integrated would be, I'll just write it out, 0 to infinity, e to the minus 1 minus I k x dx would be 1 over 1 minus I k. We now multiply the numerator and the denominator by the conjugate, which is just this with the sign flipped over. So it would be multiplied by 1 plus ix, 1 plus ix, and for the love of God, don't now just cancel these two out, like you've not done anything. Multiply this across, so you're going to get 1 plus ix, and then obviously this expanded is going to be 1 plus k squared. So the real part, we're only looking at the real part, I'll just put part here, is going to be 1 over 1 plus k squared. Now, the convolution theorem we have over here, this little fun little one, we want it to convolute with e to the minus x with itself. So that means you're going to get the Fourier transform of e to the minus x and e to the minus x with respect to k, and then that's going to then be, if we now use this and this, well actually we'll use this one a bit later, it's then going to become 2 over pi, and then what did we find? We found that this was here, so it's going to be 1 over 1 plus k squared all squared. So then the Fourier transform of fx k is going to be the root of 2 pi over 2 over pi 1 over 1 plus k squared all squared. So to get back to in terms of fx, we're going to use now this. So we're going to sub in this expression above. So you should get, hopefully I can just fit this in so I don't need to waste another piece of paper. You're going to get fx, which is 1 over root 2 pi, and the integral is minus infinity to infinity of root 2 pi 2 over pi 1 over 1 plus k squared all squared e to the ikx dk. Obviously we have a little root 2 pi here and a root 2 pi here, so if you pull that out, those can cancel. So if you've followed along so far, fx would equal 2 over pi minus infinity to infinity, and then it would be e to the ikx, this part over the numerator, divided by 1 plus k squared dk. I can't believe it. I can't believe it. Straight up, I can't believe it. Unreal.